Hello everybody and Happy New Year, I suppose. So this video is going to be about my electric bike. This electric bike, as you can see, is in a few pieces. Now, I've owned a few electric bikes over the years. This would be my fourth electric bike. The first one I had was a cheap Chinese one, a little 250 watt one. Of course, they're all 250 road legal. And yeah, it was all right, but very quickly after about 500 miles, it started to feel like it was falling apart. So I bought a different bike from another company, which was a brilliant bike. After about 3-4 years, the battery started to degrade. Had no real problems with it, to be honest, other than the front derailleur. That one there, that randomly broke internally and wouldn't work. Third one, yet again, pretty good. Other than the fact that, I mean, it was a couple of years old, and then somebody didn't pay attention to where we were going and took me out and wrote it off. That sort of finished that one off, and then I ended up with this one in a bit of a hurry. And this one, I'll be honest, it's been a little bit of a disappointment. So it's a 52 volt, 19.5 amp hour battery. The battery is actually quite an expensive item for this one. So that battery there, that's got the Panasonic Tesla joint venture cells in it that are supposed to be amazingly fantastic, wonderful. I don't think they're that great, but they work. They're all right. Now, as you can see, we've got the rear wheel out of it. So I had a problem, which is what this video is actually for. I had a problem with mine where what would happen is you'd be riding down a road and you would get a juddering from the rear hub motor. It's almost like a pulsating. Now, this happened once before last year, which is why I'm not impressed with this bike, because this is like the second time it's broke. It's broke nearly every year. This time it's cost me quite a lot of money to fix it. Now, what it was last year was quite cheap. These are the wires here from the controller that go to the hub motor. So basically these are your 3 power wires. So therefore your 3 phases of the motor, because this motors are 3 phase, and there's the 3 wires. Now these 5 here are for the position sensors in a motor. You don't have to have position sensors in a motor, but you do get a lot more torque and a lot more power out of them if you have position sensors. So you've got these 5 wires, and basically how it works, if you don't know, is you've got red, which is power, so that's 5 volts. You have the black, which is a ground, and then each one of those, the green, yellow, blue, those are your 3 different sensors. So the way this works is basically as the wheel rotates, motor, same thing we're talking about, each one of these will end up with a 5 volt signal. So basically this particular one went from 0.2 volts to 4.99 volts. The problem I had last time is that this connector here was actually a connector, which is why you can see it's got some heat shrink and some different wire on it. The reason for that is basically because this connector got corrosion in it, and that's what caused that problem. So as you was trying to accelerate on the throttle, you'd be pulling back, and it would make a noise as it accelerated, and it would sort of pulse through the whole bike, and it would feel like it wasn't as powerful, and it also flattened the battery a lot quicker. Now, I cleaned those contacts out on there, and it was fine for a little while, and then it started doing the same thing again this year. So I thought, well, maybe it's this again, most likely thing. And what I did was I basically cut the connectors off and then soldered solid wires in. Does make it a bit of a pain if you need to take the wheel out, but then to be honest with you, I've never had to take this wheel out. This is the first time I've ever taken this wheel out in 4,300 miles. 4,500 miles, something like that. So what I did was I cut that out and it still did it. In fact, it almost seemed to make it worse. And then I got about 200 yards, 500 yards on it, something like that. Basically, the fault light came up on the dash there. So I've got the UKC1 controller. Yeah, that came up with a fault lamp saying position error, which, like I say, can be to do with these 5 wires. Now, if you've got that on your bike, what you need to do to test it, we'll take you with me. Shaky cam. Right, so what you need to do to test it is you need to get it so that you can basically get to this. Turn your bike electronics on. Then you need to check that you have 5 volts on this wire. It's quite simple to do. Just take a multimeter, and you can also check your ground at the same time, and you can go from ground to power. You should have 4.99 volts or very close to. Sometimes you'll get 5.1, depends on the system, depends how it's. If you get anything around 4 or lower, then you've probably got a connection problem in the line and it's not seeing the full signal, because it's a square wave signal, just like an on off that each one puts on. Then what you can do, if you've got 5 volts and that's good, and you've got a ground and that's all good, then what you can do is you can take your multimeter, leave it in the ground, the black wire, leave that in there. Then what you do is you ignore the red wire, and you can even probe these with a multimeter and work out which is which if they're not the same colour. And then what you do is you probe, say, the yellow one with the multimeter and see if there is a voltage on there. If there is 5 volts, spin the wheel by hand, not with a motor. Spin the wheel and see if the 5 volt signal goes away. And then basically do the same for the other 2 phases. You should get on and off signals. Now, you should get it for all 3. If you don't, then that's your problem. That maybe your sensors died inside. It is a common problem with motors, to be honest with you. But what I found was all my sensors were good. And everything was working as it should on those 5 wires, which surprised me, but it was. So then what I decided to do is go for the power wires. Now, the test you can do on this side, just to check without having to take too much apart, is if you disconnect your controller from your hub motor, so you are left with 3 wires. So you've got your 3 wires there. And then what you do is take your multimeter. It's up to you how you do this. But you touch the multimeter to one, say the blue, and then you'll touch the other side to the green and then the yellow. And what that's doing is checking, and you want to check for continuity. If you've got a multimeter, set it to the beep, would be the best thing. That's what I did. And then basically if you touch any 2 of these and get a beep out of your multimeter, then you have an internal short in your motor, which will be your problem. Now, I actually had an internal short between 2 of the windings. So this winding, and I think it was this winding, were shorted. And there was resistance between the 2, which told me that I needed to open the motor up and have a look inside. Now, to open the motor up, most electric motors are the same. You take out the Allen bolts around the outside. Off one side, generally the sprocket side first. Take a hammer, dead blow hammer, and strike the shaft on the motor. Now we'll bring the motor over and we'll discuss what's actually wrong with mine and why the motor's dead. So inside the motor, when you finally get it open, you'll end up with this. Be careful when you are sliding the wires here through the bearing, because if you're not careful you can trap the wires and damage them. Now, as you can see, mine, the guy that built this, used these little block connectors, which, as you can see, those two have got hot and melted the plastic. The third one has actually burnt, so it's burnt itself up. And then you can see that's where the winding goes into the motor. Ironically, it's this phase and this phase that are shorted together, but that's the one that's melted. So I think this one's melted and shorted those two together. There had been a fire in here. Now, I obviously disconnected this side and this side because the short could have been inside the wires or anywhere inside of here, but by disconnecting either side so that there's nothing connecting anything together, there shouldn't have been anything between, because there's the other thing you need to check. Ground. If either any of these three phases are shorted to ground, I'll show you how to do that test actually while we're here. So, got my multimeter set to make a noise so you don't need to look at the screen. So if those will get a noise. So for instance, between this one, we have two shorted together. Now between this and here, we should not get a signal either, which this one actually isn't shorted to ground. So you would just touch that on there, make sure it's got a good contact, which it has, and then just go into that terminal, into that terminal, and into that terminal. Now you can do this from outside the motor by using the shaft of the motor and the cables. You can do the same test and make sure that they're not shorted together like that. So obviously for me, this is basically how it is. We are at a point of there is nothing I can do to fix this really. Now this is the sensor I was telling you about. So this is the Hall effect sensor. There's all your wires. Obviously if you've got one of these that happens to be shorted or something like that, you can also test that in here. Like I say, for me, I've bought a second-hand motor, and that second-hand motor has cost me £300. So I'm going to get that motor when it arrives and install that back into here. I'm going to clean up the bike and it's actually going to be sold. I'm going to get rid of it. It is a 2.4 kilowatt. Well, it's set up to run 2.4. So it will run 2.4 kilowatts. I have ordered a different bike, which I will do a video about when it arrives. So there we go. That's the problem I had and how I diagnosed it. Hope that helps you. Thanks for watching. Please give us a thumbs up. Let me know your comments, criticisms down below. And I'll reply to you as soon as I can. Thanks for watching. Goodbye.